Back in 2015, NASA found a planet that broke their models, a world sitting in the exact position scientists almost never find. When they ran it through the Earth Similarity Index, researchers checked their data 3 times. Because in some categories, this planet scored higher than Earth itself. A rocky world 1,200 light-years away, outperforming our own home. They named it Kepler 442b. And what makes it so remarkable comes down to 3 specific reasons. 3 reasons that force scientists to rethink where life could exist. Reason 1. The perfect location. NASA's Kepler telescope was scanning a small patch of sky in the constellation Lyra when it caught a tiny flicker. A quiet orange star dimming for just a moment. That flicker meant something was passing in front of it. A planet. When scientists measured its size and position, the room went quiet. Kepler 442b was sitting in what they call the habitable zone, but most people know it by another name, the Goldilocks zone. Just like the fairy tale, not too hot, not too cold, but exactly right. A planet must orbit at the precise distance where liquid water can exist on its surface. Too close to the star, and all water boils into space. Too far, and everything freezes solid. Kepler 442b orbits at 0.409 astronomical units, about 40% of Earth's distance from our Sun, placing it almost perfectly inside this zone. Scientists estimate its surface temperature could range from -40 degrees to comfortable Earth-like conditions. At that range, liquid water is not science fiction. It is a genuine possibility. But even the perfect location means nothing if the star itself is violent and unstable. Reason 2. The patient star. Every planet is only as good as the star it orbits. Ours gives us warmth and light, but it also has an expiration date. Our Sun will burn out in about 5 billion years, and long before that, it will expand and swallow the inner planet's whole. Kepler 442b does not have this problem. It orbits a K-type orange dwarf, a smaller, cooler star that burns its fuel slowly and steadily. Think of it like a candle that refuses to flicker. K-type stars produce less harmful ultraviolet radiation than our Sun. They release far fewer deadly solar flares than red dwarf stars. And here is the part that changes everything. A K-type star can burn for up to 30 billion years. That is 3 times longer than our Sun will ever last. On Earth, it took nearly 4 billion years to go from the first living cell to creatures that could wonder about the stars. Kepler 442b has 3 times that runway. If life started there when it started here, it would have no deadline. No countdown, just billions of years of uninterrupted evolution. But even the perfect location and the most patient star cannot help a planet caught in one silent trap. A trap that destroys almost every world like this one. Reason 3. The Great Escape. Here is the danger nobody talks about. Most planets orbiting close to smaller stars fall into something called tidal locking. The star's gravity grabs hold of the planet and stops its rotation completely. One side faces the star forever, burning in permanent daylight. The other side faces away forever, frozen in endless night. No sunrise, no sunset, no cycle. Just 2 dead halves of a world that could have been alive. For Kepler 442's system, the danger line sits at 0.362 astronomical units. Any planet orbiting closer than that distance gets locked. Kepler 442b orbits at 0.409 astronomical units. It escaped the trap by just 47 million kilometers, a razor-thin margin in cosmic terms. That means this planet still rotates. It still has day and night. Heat still spreads across its surface. And that single fact makes everything else possible. But when scientists looked closer at Kepler 442b's size and mass, they found something else, something unexpected. The super-Earth advantage. Kepler 442b is not Earth's twin. It is Earth's bigger cousin. Its radius stretches 1.33 times wider than ours. Its mass pulls 2.36 times heavier. Scientists call planets like this super-Earths. Rocky like our world, but with 30% stronger gravity pressing down on everything. That extra gravity is not a weakness, it is an advantage. Stronger gravity means the planet can hold on to a thicker atmosphere. The invisible shield that protects life from radiation, regulates temperature, and keeps water from escaping into space. But here is the honest truth scientists cannot ignore. Just because Kepler 442b could hold an atmosphere does not mean it has one. No telescope has ever seen it directly, and that single missing puzzle piece has haunted researchers since the day this planet was discovered. The visibility problem. Kepler 442b sits 1,200 light-years away. Even the James Webb Space Telescope cannot analyze its atmosphere at that distance. We know its size, orbit, and star, but whether air wraps around that world remains invisible. It is like finding a locked chest at the bottom of the ocean with no key. But scientists are not waiting. In Chile, engineers are building the European Extremely Large Telescope with a mirror 39 meters across. NASA is designing the Habitable Worlds Observatory, built specifically to find Earth-like planets. These instruments will search for biosignatures, combinations of gases like oxygen and methane together. On Earth, that combination only exists because living things produce it. Finding both on Kepler 442b would be the strongest evidence of alien life ever recorded. What life might look like. Consider this carefully. If Kepler 442b has liquid water, a thick atmosphere, and 30 billion years of stable conditions, how far could life evolve? On Earth, 3.8 billion years transform bacteria into whales, forests, and civilizations. Kepler 442b has 3 times that window. Scientists speculate creatures there might be shorter and denser, evolved to handle stronger gravity pressing on their bones. Plants might not be green at all, under orange-red starlight. Vegetation might evolve black pigments to absorb every photon. And if intelligent life emerged there when it emerged here, it has had billions of extra years to keep evolving. No asteroid extinction, no solar deadline, just continuous evolution towards something we cannot imagine. The distance barrier. But one hard truth remains. The light reaching our telescopes tonight left Kepler 442b around 825 AD, when Vikings raided coastlines and the Tang dynasty ruled China. At our fastest spacecraft speeds, the journey would take 1.8 million years. We cannot visit. We cannot send probes. Everything we learn must come from light alone. But here is what most people miss. Finding this planet was never about reaching it. It was about proving places like it exist. Scientists now estimate 40 billion Earth-like planets could be scattered across our galaxy. Kepler 442b is not the destination. It is proof that destinations exist. Closing reflection. 3 reasons. A perfect location in the Goldilocks zone. A patient star burning for 30 billion years, and a narrow escape from the trap that kills most worlds like it. This is not speculation. This is measured science from a real planet 1,200 light-years away. But here is what stays with me. If one small patch of sky revealed Kepler 442b, what are billions of unsearched stars still hiding? The question is no longer whether life exists out there. The question is how long until we find it. And somewhere in Lyra tonight, beneath an orange sun that will outlive ours by eons, a quiet world is slowly turning, unaware that a curious species has already found it and started dreaming. 3 reasons, 1 planet, and the oldest question we have ever asked. Is anyone else out there? Kepler 442b does not answer that question, but for the first time, it gives us a real place to look. If this changed how you see the night sky, tell me in the comments. Do you believe we will find life beyond Earth in your lifetime? Subscribe if you want to keep exploring the universe with me. This conversation might be the most important one our generation ever has.